We always get Monday. Let's
Okay. Lesson 7-6 is our last lesson in chapter 7. Woo-hoo. My plan is 7-6 today and tomorrow if necessary. And then Monday we'll talk chapter 7 review for test a week from today. And a week from tomorrow, you'll be on spring break.
Yes.
Okay. So what's that mean? 5 school days left?
Yes.
Because today's already started, so we don't count it, right?
Right.
Okay. Man.
Oh, darn it, and I copied you.
Okay, well, I obviously have an issue with what today's date is. Don't copy my date.
For being a math teacher, you have a lot of issues with numbers. You do that very often.
It has nothing to do with a number. I just couldn't remember what the date was.
It does, but it does.
Okay, so we are talking about natural logarithms today. When we were working with logs yesterday, we were working with common logarithms. They were log logs, right? And most, if not all, the ones we worked with yesterday were base 10. We've also worked with some other logs, log base 3, 4, whatever. But today we're talking about natural logs. I mentioned natural logs a little bit earlier, I don't know, somewhere back in the beginning of the chapter. But a natural logarithm is basically log base e. And if you recall, there's an e button on your calculator, right? Okay, so a natural log is log base e. Because it is log base e, and because it's a special log, we have a specific way we write it, and that is ln x. So ln representing natural log. Now, you also have an ln button on your calculator, and that's the button we're going to be using today. Instead of the log button, you're going to be using the ln button. Now, e is referred to as the natural number. It's a lot like pi in that it is irrational. E, if you punch e on your calculator, now you might have to make it e to the power of 1, but 2.718, so on and so forth is what I usually say.
Yeah.
That's what e is. Again, if you want to see a longer version of e, do e to the first on your calculator. Unless you can just do e on your calculator. I think mine, I have to put a power of 1 with it. Okay? So, everything is natural log. Now, a summary of what we're doing in lesson 7.6. Everything we did in lesson 7.5, maybe 7.4, I can't remember, but with natural logs instead of regular logs. So we're still practicing our properties, we're still going to solve some equations, we're still going to simplify some expressions. We're just using natural logs instead of common logs. So, example 1. What is each expression written as a single natural logarithm? We did this back in lesson 7.4 using regular logs, yes? We had to take multiple logs, put them together as one log. So this is our properties from 7.4. So, thoughts on how to rewrite 2 natural log of 15 minus natural log of 75? What's the first step that has to be done? No. You're thinking we're solving equations. We're not solving an equation here. Okay. Before we can think about subtracting, hold that thought because we are going to go there. We can't use our quotient property until we use our power property. Okay? We can't look at the fact that, oh, this is 2 logs being subtracted until we have nothing out front. So the power property says what? You can take this coefficient of 2 and put it up as the power. So 2 natural log of 15 can be rewritten as natural log of 15 squared. Still minus natural log of 75, of course. And if you want to go ahead and square 15, you can. I will later. Now, 2 logs being subtracted can be rewritten as 1 log where the insides are divided. So I'm going to rewrite this as 1 log where the insides are divided. What goes on top? 15 squared over 75. So it's always the first number over the second number. Now, if you haven't already, what is 15 squared? 225. What is 225 divided by 75?
3.
So this is the natural log of 3. And our job was to write it as a single natural logarithm. Did I do that?
Yeah.
I did. You could have parentheses around the 3. You don't necessarily have to have parentheses around the 3, though, when it's just a single digit. Okay. So I reviewed power property and quotient property. Example B. Natural log of 7 plus 2 natural log of 5. What do I have to do first? Power property. I can't put these together until I have no numbers in front. So this 2 can move up and become a power. So natural log of 7 plus natural log of 5 squared. Now what?
You can square your 5s, or you can just multiply.
Okay. Okay. 2 logs being added can be rewritten as 1 log, where the insides are multiplied. So 7 times 5 squared, or if you already did 5 squared, it's 7 times 25. What's 7 quarters? 175, so natural log of 175. Okay, these are all these properties, right? Just reviewing the properties. Okay, C. 3 natural log of x minus 2 natural log of x. Okay. Power property. This time I have powers I have to do on both of them, right? 3 natural log of x is going to become natural log of x to the third minus 2 natural log of x is going to become natural log of x to the second. Now what? 2 logs being subtracted can be rewritten as 1 log where the insides are divided. So natural log of x cubed over x squared. Can I simplify that one farther? Can x to the third over x to the second simplify?
It's just x.
They have the same base, right? So how do you divide when they have the same base? You keep the base the same and subtract the exponents. 3 minus 2 is going to be 1. So natural log of x. Ironically enough, and this only works because they're the same insides, but notice 3 natural log of x minus 2 natural log of x ended up being 1 natural log of x. Not coincidence. It mathematically makes sense. Okay, D. 3 natural log of x plus 2 natural log of y plus natural log of 5. First step is, okay, power property on the first 2 at least. 3 natural log of x becomes natural log of x cubed. 2 natural log of y becomes natural log of y squared. plus natural log of 5.
So you just leave it.
We're not just going to leave it. We're not going to stop there. I'll tell you about the natural log of 5.
Yeah, I got confused.
Okay, yeah, the natural log of 5 we just carry down. There's no number out front to put in the power.
Yeah, I got confused.
Now, 3 logs being added. Can be rewritten as 1 log being multiplied. Okay? Gentlemen, let's pay attention back there, please. We can't afford distractions. So, natural log of x cubed plus natural log of y squared plus natural log of 5. We're going to have natural log of x cubed times y squared times 5. Could I make this a little nicer, though? I'll be honest, this is not how I would be writing it as a final answer. Although, might MathXL take it in this order? I don't know. For me, when I have a constant multiplied by variables, I tend to put the constant in front of the variables. So for me, when I write this, I would say this is a natural log of 5x cubed y squared. That's it. Our goal in this section is to rewrite it as 1 log, yes?
Yep.
And I did that. So, yep, that's it. Okay, one more. Then we're going to go solve some equations. 2 natural log of 3 plus natural log of 8.
Natural log of 3.
Okay, so we can't add these logs until we get the number out front. So 2 natural log of 3, power property, natural log of 3 squared plus natural log of 8. Did you get it? 2 logs being added is 1 log where the insides are multiplied. And you are always welcome to go ahead. You don't have to write 3 squared. You can go straight to the 9 on there. I just want to make sure people see where it comes from. Natural log of what? 72. 3 squared is 9 times 8. 72. Notice on something like natural log of 72, I didn't put parentheses. I don't necessarily have to put parentheses. Did you notice on the previous one? This previous one would be wrong without parentheses because there's multiple pieces in there. So do be careful.
What?
Questions? Yes?
So if it's like a singular number by itself, you don't need to put parentheses?
No.
So like,
Unless MathXL forces you to, but normal rule of thumb, if it's just natural log of something, you don't have to put parentheses unless there's multiple things within the log.
so for like 3 and 175 on the first 2?
You would not have to have parentheses around the 3 and 175 over here. You can, but you don't have to. Okay.
Would it like get it wrong if we did it?
I can't speak for MathXL because we all know MathXL has its own mind of what it wants to do.
On the test, would you count it wrong?
No. Yeah. So I can count for myself, but I can't talk for the test. Or I can talk for myself in the test. I can't talk for MathXL.
Honestly, don't you make the test?
Yes. I make the test, so thus I can, and I grade the test. That's what it comes down to. I grade the test, so I get to judge how that goes. Okay. Bottom of the front side.
Sure.
Let's go with it.
Yes.
Okay. So, top, we were just using those properties. We've used them before. We were just putting them in a new setting. Bottom, we're solving equations. We've solved equations before. That's what we spent the last 2 days doing. Now we are learning how to solve equations that have natural log instead of log log. So,
Don't they mean the same thing?
yeah, just different bases. Natural log of x minus 3 squared equals 4. Think back to last night's homework. Think back to yesterday's notes. How do we solve when there is a log in the problem? Left, right, middle. Does left, right, middle sound familiar?
Yeah.
It should. If it doesn't, you must have been sleeping the past 2 days or haven't been here. Now, left, right, middle. In order to do left, right, middle, we have to know the base. What is the base on example A? What was it?
10.
No. E. These are natural logs, right? When no base is written on natural log, this is base E. So you have to remember there's an invisible E there.
I don't like that.
So keep in mind, E is a number. It's not a letter, it's a number.
It's like
It's like pi, exactly. So left, right, middle says, what's left? E to the right number, 4, equals the middle. What's in the middle?
x minus 3.
X minus 3 squared. Okay. I have to ask you a very important question here. What are we solving for? X, correct? And I ask that because it's so easy to get confused and say, oh, I see E, there's a variable, we're solving for E.
No, it's a number.
It's a number. E is a number right now, okay? Don't tell Miss Minnick that, or Mrs. Holman, but E is a number right now. Okay. How do we solve for X? Because this is X minus 3 squared equals some number.
X minus 3, x minus 3.
No. I don't want to foil, because that's the direction you're taking me, and that's going to take me ugly. What'd you say?
Square root.
How about we do the opposite of squaring it and square root it?
Oh boy.
We've done this. This will be much better than foiling, I promise. Okay? Now, x minus 3 squared. How do I get rid of the square? I take the square root. If I take the square root on one side, we take the square root on the other side. Now, I'm going to flip these sides in my next step. Keep in mind we're solving for x. What is the square root of x minus 3 squared?
X minus 3.
Whatever's in those parentheses, right? So the square root of x minus 3 squared is x minus 3. Now, I don't want a calculator answer right now,
Can you do that?
but the square root of e to the 4th. How do we take a square root of a power? To take a square root of an exponent, you take that exponent and divide it by 2. So the square root of e to the 4th is e to the 2nd, because you're doing 4 divided by 2. Now, we just took the square root in an equation setting. When you take the square root of both sides of an equation, you have to consider,
Absolute value.
no,
Plus or minus.
plus or minus,
Oh,
the positive value and the negative value.
well, that's not very nice.
So, we're going to have x minus 3 equals plus or minus e squared. You have to get that plus or minus on there because we just went from having one possible answer to 2 possible answers. Okay, how do I solve for x?
Yeah.
If it's x minus 3, I'm going to add 3. Now, with that in mind, I'm going to have x equals, and you can put the 3 out front or out back. When I have a plus or minus, I like my plus or minus to be in between two things. So that means I like to say this is 3 plus or minus e squared. That's what I like. Now, if you would rather say plus or minus e squared plus 3, that works as well. Okay. We have how many answers to this problem? 2. The directions say to the nearest thousandth, which means I need decimal answers, right? So this means this is where the calculator comes into play. We're going to have to figure out what is 3 plus e squared and what is 3 minus e squared to 3 decimal places. So grab your calculator and practice. Same thing I've said in the past. Practice while you can. Practice while I can help you find your mistakes, right? Okay, have you figured it out? I would enter this all as 1, like 3 plus e squared. So I would say 3 plus, and then my e is right above my LN button for me. So since my e is above my LN button, I have to do second LN button. So that gives me e, and it's e to what power? E to the second. So that right there is doing 3 plus e to the second. Does your calculator answer match my calculator answer?
Yes.
Yeah.
Maybe you have a different calculator, maybe you did things in a different order. Do you know what you're doing? Because you could have done e squared in your parentheses and then plus 3, and it's possible. You just have to know how to use your calculator.
So it doesn't matter what way you put it.
It does to an extent. You just have to be careful. Because especially in the next one where it's minus. So one of my answers, what's this answer? 10.389. Repeat the process. Get your other answer. 3 minus e to the second. Does your answer match my answer?
Yeah.
Negative 4.389. Now, is a negative answer okay here?
Yes.
Yes.
Whatever you say.
We have to check, right? And I'm not getting fancy with my check, but what happens when I put a number in here? I'm going to subtract 3, but then what do I do after I subtract 3? I'm going to square it, right? And when I square it, whatever I have there is going to become positive. And that means the inside of my natural log is positive, and so negatives are okay on this problem.
Yay.
Okay? Why don't you guys start B?
Started?
Yeah. Well, here, I'll help you get started, and I want you guys to do solving. What base is natural log again?
E.
E. So what's my equation I'm going to write?
E to the fourth equals 3x plus 5.
Okay. Left, right, middle. E to the 4th equals 3x plus 5 squared. Actually, I might be able to get done with this one if we get moving. I'm trying to solve for what? X. So if it's 3x plus 5 squared, what are we going to do? I don't need to FOIL it out. I just need to take the square root. What is the square root of 3x plus 5 squared? 3x plus 5. Good. What is the square root of e to the 4th?
E to the second.
E to the 2nd. And since we're in an equation setting and we took the square root of both sides,
You have to subtract.
has to be plus or minus. Okay. If it's 3x plus 5, solving for x, I'm going to subtract 5. When I subtract 5 on this other side, my recommendation is that you put the negative 5 out front. So negative 5 plus or minus e squared. And how do I get x by itself? If it's 3x, we're going to divide by 3. And so you're going to have to do this on your calculator 2 different times. Negative 5 plus or minus e squared divided by 3. You have to work to know how to use your calculator here. Should we check those answers at the beginning of class tomorrow?
Sure.
We'll check those answers at the beginning of class tomorrow. Make sure that you finish the calculations, right? You are welcome to start the homework. You'll know how to do some of it, right?